The tools will arrive via truck or supply vessel at the rig site. The shipping papers have to be checked against the placed order to determine which tools have been delivered. Upon arrival at the rig, the motor should be visually inspected to determine its conditions and check for damages. The serial number for each motor is stamped on a brass plate set into a milled slot, which is located on the bit sub or drive sub of the motor. A container with all hull shells is screwed onto the drive sub box connection for each motor. For 9.5 inch and larger motors, the hull shell box is shipped separately. The motor type can be determined by examining the brass plate set into a milled slot on the stator housing here. The most critical information for a DD is a power section type and elastomer type here. That's how this brass plate on a stator housing looks like, and that's exactly where we can find the information about the power section type, about the elastomer type, and if necessary to confirm nominal stator OD. Hull shell AKO design features adjusting ring, wear ring, and 2 hull shells. Also, it has only one connection here. Add another visit. Whereas double pin AKO design has 2 connections and features the sleeve with alignment mark and wear pad. For our example, let's assume that we have 9.5 Ultra XL VS motor with D elastomer and half shell AKO design, and we are going to use this motor in 12-inch hull section. Once motor type was identified, now fishing diagram can be downloaded, printed and filled in. So we're looking for 9.5 Ultra XL motor with half shell AKO design. So this is a fishing diagram, and we have nominal dimensions here for a newly manufactured motor, and this is something DD has to fill in while at the rig site. So fishing diagram is pretty straightforward and self-explanatory. Thread types must be checked and confirmed as well. If we have sleek configuration of a motor, then we just don't record any UBHS OD. We just treat the bearing housing as a sleek, having constant diameter. DD must check if float valve was installed properly and working. It can be done simply pressing on the float valve. For hull shell AKO design for any particular AKO setting, DD must confirm that required hull shell were supplied and check their widths according to pre-job procedures. So how to use this table? Let's say we are talking about this Ultra 9.5 inch motor. So that's exactly where we are right now. So that means this column represents the necessary widths of the hull shell in order to achieve any particular AKO setting. Let's say if we are talking about 1.2 AKO setting, then nominal widths of the hull shell must be 0.457 inches. all motor specifications can be found in Motor Handbook. So now I just have to find correct motor. It will be 9.5-inch Ultra XL VS. So I scroll all the way to this motor. So this information on the left side of the page shows the configuration that are common for all 9.5 Ultra XL motors, regardless of the power section type. So we can have lengths, weight range here, the bit size range, and other specifications. And if we are interested in the particular configuration of the power section, now we have to find exactly our power section mark, and this is exactly what we're looking for, 9.5 Ultra XL VS. Now from this table here we know the flow rate range, the speed range, the speed to flow ratio, and we have both US units and C units as well. So from this table also you can see that let's say operational limits, they will be duplicated for a standard or high temperature elastomer and for Duramax elastomer. So now which one to pick depends on the elastomer that you actually have in your power section. We already said that in our case elastomer type will be D, that stands for standard elastomer. That means that this information applies to my motor configuration.